Dear students, very good afternoon. Today we are going to see one important verification. Okay, because not all the students will solve the problem in the same way. Okay, so that the result may vary. So whether the answer is correct or not, how to conclude that, it is what we are going to discuss today. So under Laurent series we are going to discuss one important problem. I'm going to do that problem in two ways. So here is the question. Obtain the Laurent series expansion for f of z equal to 1 divided by z minus 1 into z minus 2 valid in the regions First question is modulus of z minus 1 less than 1. Second question is 1 less than modulus of z less than 2. Third condition is modulus of z greater than 2. Okay, so first we shall discuss this problem and we shall discuss another problem also. So I am going to concentrate on the particular case called this case. So solution, what they have given, f of z equal to 1 divided by z minus 1 into z minus 2. They have given the region as modulus of z minus 1 less than 1. Okay, modulus of z minus 1 less than 1. This is given. Okay, I am going to do this problem in two cases. Okay, so before that I shall draw the circle for this. So this circle, if I am considering this as circle, that is, if I am taking modulus of z minus 1 equal to 1 means, if then center will be 1, 0, radius will be 1, but here they have given less than 1. So if it is less than 1 means my radius is also less than 1. So if I am drawing the circle means center is not the center is 1, 0. 1, 0 means in x-axis I will have 1. So this is 1, 0. Here I will have 2 and here I will have 0. So less than 1 means this 0 will not be touched and this 2 also will not be touched. Okay, so this is 2. Okay, so draw a circle once again. Closer but it should not touch. Okay, it is closer for 2 but should not touch 2. It is closer for 0 but it should not touch 0. Okay, then only radius is less than 1, it means. Okay, now this z equal to 2 will definitely lies outside. Okay, z equal to 1, at z equal to 1 means, see, at z equal to 1 means what does it mean? X equal to y equal to 0, it lies inside, but at z equal to 1 and z equal to 2, the function will its analyticity, because the denominator becomes 0, so the function will become infinity. So f of z is not analytic, okay, not analytic at 2 points, z equal to 1 and z equal to 2. These 2 points are singularities. Okay, so okay, now for Laurent series it is not necessary to mention this. So what we have to mention? We have to mention it is not necessary to mention, but we shall write it. Okay, and because z equal to 1 and z equal to 2, so I am not, since it is not analytic because they are taking modulus of z minus 1 less than 1. Okay, now we are going to solve this according to the region. They have given in the region, given modulus of z minus 1 less than 1. So we consider this modulus of z minus 1 equal to, okay, we consider this z minus 1 equal to u. It will imply modulus of z minus 1 less than 1 implies modulus of u less than 1. That implies modulus of u by 1 less than 1. Okay, so we shall now consider the given function. What is our function? F of z equal to 1 by z minus 1 into z minus 2. That can be written as 1 divided by z minus 1 into z minus 1 minus 1, z minus 1 minus 1, and after that we will have f of z equal to 1 divided by u into u minus 1. F of z equal to 1 divided by u into u minus 1. Okay, so now this is our function. I am going to solve this function in two ways. So students can follow one way, but I will prefer one method. Okay, in the last I will tell which method I prefer. Okay, so but I shall give you the solution in two ways. Okay, the solution in two ways. In first case, I am going to consider this f of z as 1 divided by u into 1 divided by u minus 1. That is 1 by u into, we have taken modulus of u by 1 less than 1. So I have to make this 1 outside. So I am taking, if I take 1 outside means it will become 1 minus 1 by u, 1 minus 1 by u, but it is not necessary. So for binomial expansion, it is not necessary for the binomial expansion, but since we just only want to make binomial expansion, so simply take the minus outside, so it will become minus 1 by 1 minus u. So we will get 1 by u into minus 1 into 1 minus u whole power minus 1, that is equal to 1 by u into minus of 1 plus u square plus etc. Okay, plus etc. I am putting. Then after that we can write it as this is equal to 1 by u into minus summation of u power n, minus summation of u power n equal to 0 to infinity. Okay, now I am writing this 1 by u as u power minus 1, u power minus 1 into minus of summation n equal to 0 to infinity u power n. So in the next step it will become, okay, in the next step it will become minus summation n equal to 0 to infinity u power n minus 1. Okay, u power n minus 1. It will become like this. Okay, this is our f of z. Okay, I shall stop the solution here before going to next step, but I shall give you another solution in another method. Okay, another solution in another method. Okay, see, I am considering the given f of z equal to 1 by u into 1 by u minus 1, that is equal to a by u plus b by u minus 1. I am taking a into u minus 1 plus b into u equal to 1. So a equal to put u equal to 0 implies u equal to 0 implies a equal to minus 1. Put u equal to 1 implies b equal to 1. So we will get the values. A equal to minus 1, b equal to 1. So our function f of z will become minus 1 by u plus 1 by u minus 1, that is equal to minus 1 by u plus, since the region modulus of u by 1 less than 1, I am taking 1 by 1 minus u. In the numerator we are taking minus. Okay, numerator we are taking minus. So now we will have minus 1 by u minus or plus minus 1 into 1 minus u whole power minus 1, that is equal to minus 1 by u minus 1 into 1 plus u square plus etc. So that is equal to minus 1 by u. Okay, minus 1 by u minus summation of n equal to 0 to infinity u power n. Okay, see, you can see the difference. Okay, you can see the difference. Before that I shall give you another thing. This is equal to minus 1 by u. Now it will become u power minus 1 minus summation n equal to 0 to infinity u power n. See, here we are having u inverse into minus of summation n equal to 0 to infinity u power n. Here we are having minus u inverse minus summation n equal to 0 to infinity u power n. So which answer is correct? That confusion will arise. Okay, so here we are having some different answer. This is our f of z. Okay, here we are having some different answer, and there we are having some different answers. So under two different methods we are getting two different answers. Which method to follow? So that will be the very great confusion for us. Now you have to see carefully. Now I am going to rewrite this expansion in the following way, putting n equal to 0. Well, if I put n equal to 0, what will happen? Minus 1 by u. Okay, if I put n equal to 0, I will get minus 1 by u, because it will become u power minus 1. Okay, minus, it will become u power minus 1. If I put n equal to 1, it will become 0. So u power minus 1 plus 1 plus, if I put 2, it will become u power 1 plus u square plus etc. This is equal to minus of 1 by u plus 1 plus u square plus etc. This is equal to minus of 1 by u plus summation n equal to 0 to infinity u power n. U power n. I got the result. That is the result I am having here also. Minus, so this can be written as u inverse. This can be written as u inverse. So now consider this can be written as f of z equal to minus of u power minus 1 plus summation n equal to 0 to infinity u power n. So this result is correct means the result you obtain here also correct. The result you obtain here also correct. That is, this is also correct. That is, this is also correct. So why I am stressing that this result is correct means this result is the result obtained, can be obtained by using partial fraction. Okay, so if you are applying partial fraction means you apply, you will get this result only. See, you will get this result only. See, if I take minus common outside, I will get the result minus of u inverse plus summation n equal to 0 to infinity u power n. U power n. So both the results are correct. Okay, so don't get confused. So for our problem, for this kind of f of z, we will have two results with two different methods, but both the results can be simplified till the end to give the same result. But we have to be very patient to solve till the last step. Okay, so I shall give you the final result. F of z will be, see, f of z will be either minus u inverse plus summation n equal to 0 to infinity u power n, or f of z equal to minus u inverse into, in the above step we are having minus 1 into minus u inverse, sorry, it is plus u inverse, okay, I shall take the minus outside. Okay, minus summation n equal to infinity u power minus 1, minus summation n, minus summation n equal to infinity u power n minus 1. Okay, or this step u inverse into minus of un, or this step. Or f of z equal to minus u inverse into summation n equal to 0 to infinity u power n. See, in the result we are having plus in between, in this we are having into in between. Okay, which is correct? Both of them are correct. Both of them are correct. Both of them are correct. So I shall explain you why they are correct. Okay, with another example. Okay, I shall explain them with another example. So now the problem is not yet completed. I shall consider now this f of z. this f of z. I should consider now this f of z. So f of z equal to minus of what is u? Z minus 1 whole power minus 1 plus summation n equal to 0 to infinity z minus 1 whole power n. Z minus 1 whole power n. Okay. So this is our result. This is our result. Okay. Now there are two more steps. They want us to evaluate. See, I have explained two different methods to arrive at two different answers, and finally I have shown both the results are same. So in examination you can try either of the way, but I have told you know what is my preference. My preference is always going with this method. This method is partial fraction method. Always prefer this. This method is very important. Okay. Always prefer this method. Okay. Okay. Now, so the second thing we want to evaluate is 1 less than modulus of z less than 2. 1 less than modulus of z less than 2. So I'm considering f of z equal to a by z minus 1 plus b by z minus 2. Okay, that is equal to 1 divided by z minus 1 into z minus 2. So we'll have a into z minus 2 plus b into z minus 1 equal to 1. So put z equal to 2 and z equal to 1. We get b equal to 1. Put a equal to minus 1. So we get f of z equal to 1 divided by a is minus 1. So minus 1 divided by z minus 1 plus 1 divided by z minus 2. So in this step we can make that change. In this step we can make the change. In this step we can make the change. So they have given regions 1 less than modulus of z less than 2. It is given. So 1 by z will be less than 1 and z by 2 less than 1. Z by 2 less than 1. So I am considering minus 1 divided by z. If it is 1 means I have to take z common outside. So 1 minus 1 by z plus 1 divided by 2 into, I have to take minus also, so that I will get 1 minus z by 2. So here I am having minus 1 by z of 1 minus 1 by z whole inverse plus minus 1 by 2 of 1 minus z by 2 whole inverse. Since I am having minus inside and outside, that is in the exponent, I will have minus 1 by z of 1 plus 1 by z plus 1 by z square plus etc. plus or minus 1 by 2 into 1 minus z by 2 plus, so it is plus 1 plus z by 2 plus z by 2 the whole square plus etc. Okay, so plus etc. Okay, now I shall write it as minus 1 by z of summation n equal to 0 to infinity u power n minus 1 divided by 2 of summation z, sorry, it is not u, here we are having z only, so minus 1 minus 1 by z of summation n equal to 0 to infinity 1 by z whole power n, then here we will have minus 1 by 2 into summation n equal to 0 to infinity z by 2 whole power n. So I can take this z inside so that to have or else we can keep it like this, or at least summation n equal to 0 to infinity 1 by z whole power I think it will be n plus 1 minus 1 by 2, so it will be summation n equal to 0 to infinity z power n by 2 power n plus 1. So this will be our expansion. Better you can stop in the previous step itself. Okay, so dear students, the only thing is till where you are clear, do the sums up to that result. Okay, so doing the problem till this will not give you an additional mark. This itself is an answer. Okay, these two are having same meaning. Both this and this are having same meaning. So it is not necessary to continue after this step. But if you are doing that means it is well and good. But it is not necessary to do that. Okay. So in the book they have stopped till this only. Okay. Till this only. So you can stop there itself. So the region of validity is what? The region of validity is, you have to write the region of validity is 1 less than region of validity is 1 less than modulus of z less than 2. Okay. So what is our final case? Our final case is, dear students, now we shall move to the calculation part of our tier question. Under the problem, they have given the region, given modulus of z greater than 2. It implies modulus of z greater than 2 means it is 2 less than modulus of z, so it will become 2 by z less than 1. 2 by z less than 1. If 2 by z is less than 1 means it will automatically implies I am divide the entire thing by 2, it will become 1 by z. So 1 by z will also less than 1. Okay. So now in the expansion of f of z, so f of z equal to 1 divided by z minus 1 into z minus 2 that can be written as 1 divided by what is our a? A is minus 1 by z minus 1. Our b value is plus 1 by z minus 2, that you can verify in the previous step. A equal minus 1, b equal to 1. So you will have this minus 1 by z minus 1 divided by 1 plus z minus 1. Now the thing is, we have to take z outside. 1 divided by z of 1 minus 1 by z, okay, plus 1 divided by z of 1 minus 2 by z, that is equal to minus 1 by z of 1 minus 1 by z whole inverse plus 1 by z of 1 minus 2 by z whole inverse, that is equal to minus 1 by z of 1 plus 1 by z plus 1 by z the whole square plus etc. plus 1 by z of 1 minus 2 by z, that is 1 plus 2 by z plus 2 by z the whole square plus etc. So this is equal to, I am multiplying everything by minus of 1 by z. So minus 1 by z, then minus 1 by z square, then minus 1 by z cube minus etc. plus 1 by z, then plus 2 by z square, then plus 4 by z cube plus etc. etc. So this minus 1 by z and plus 1 by z will get cancelled. So we will have 2 minus 1 is 1, 1 by z square, 4 minus 1 is 3, plus 3 by z cube. Here our next term will be minus 1 by z power 4. Here the next term will be, what will be next term? The next term will be 2 by z whole cube. So 2 cube will be 8 by, here next term will be 2 cube by z cube, 2 by z whole cube, by z the whole cube plus etc. So 2 cube will be 8 by z power 4. So 8 minus 1 is 7, plus 7 by z power 4 plus etc. This will be our f of z. I hope you all understood the problem. The problem is very, very important. So thank you all for watching this video. Thank you all once again.